Hi Yr7, welcome to the video. The idea of the video is to try and help you to know how to plan your time each week in the last weeks of Year 7, and also to help you with some of the work that you found tricky last week, just before half term. So, first of all, each week you've got 3 science lessons on a Wednesday, Thursday and Friday. On that Wednesday lesson, please complete the first online lesson. On the Thursday, so that's the second lesson of the week, please complete the second of the online lessons that we're posting for you every Monday morning, and we'll continue to do that each week throughout the rest of this year. So those 2 online lessons are done in those first 2 sessions each week on your timetable. Then you can complete the quiz, which should only take about 10 to 15 minutes of your time. And that's your work done for those first 2 lessons. There is a homework slot, which you'll have seen, and that's on a Thursday afternoon. The best way to spend that is to have a go at that quiz again. If you need to, go back and have a look at those online lessons, or even one of those lessons, or a half of one of those lessons, which you know you struggled with, and watch that part again. Use that to try and help improve your score on the quiz. We really want you to do the quiz once and then try it again a second time and make an even better attempt on that third try. And so many of you are doing it. It's really fantastic to see your scores improving. And it works so much better when you've gone back and looked at the content again. Now, some of that content is tricky, and that's where this video comes in. I want to explain to you some ways that the team, Miss Jones, Mr. Gillespie and myself, who are running the work for you in this last half term, what we want to do to try and help you in the coming weeks. So firstly, we've got this video which will help you with that. We've got secondly, some past paper questions which we've now placed on Show My Homework for you, and it's a great way to practice the content of the online lessons and how you would use that to answer a question in an examination. And of course that's going to be really important when you get back to school eventually and you're doing ROA exams and you're having to answer these sorts of questions. The mark schemes are attached, so it gives you a chance to go through the answers that you've put in and to then get a score at the end of it and make corrections to any bits that you got wrong, any questions. If you're still struggling with that, what we'd really like to do, and we're going to start this on Friday this week, in the second half of your lesson on Friday, so at 12:15, you will be able to join us on a live question and answer session on Teams. Look on Show My Homework, there will be instructions on there for you so you can get access to Teams. Now you don't have to come on there, but we would love to see as many of you on there as possible. Even if you're just there to watch and to listen to some of the answers that we can give to questions that other people have. Okay, so there's no pressure there, you don't need your camera on, you don't need your mic on, and you can put questions in the chat, but it would be great to see some of your faces and for you to get involved as well. So please keep an eye out for that. Now please also bear in mind with your work that this all due in on Fridays. I know this week we had a mix-up with the Wednesday deadline. There will not be any Wednesday deadlines for you in Year 7. It's all going to be on Friday. That should give you plenty of time then to work through all of your tasks. So I hope that really, really helps, and we'd love to see you on Friday. So let's move on to something that you struggled with in the last piece of work, converting units. This is basically a math skill, which you probably will have done at some point in the past, but if you need help with that, I'm just going to quickly run through it now. So N here is our unit for measuring forces, and it's newtons. Now the K here stands for kilo, and kilo you probably heard in kilometre, which means 1,000 metres, or kilojoule or kilojoule. That means 1,000 joules of energy. So kilo means 1,000. So if we have a little look at what a kilonewton actually is, then we see that 1 kilonewton is 1,000 newtons. So how do we get from 1,000 newtons being exactly the same as 1 kilonewton? We have to take that number and divide it by 1,000. So that's as complicated as it gets. You take the number, you divide it by 1,000. What if we had half of that amount? What if we had 500 newtons, and we wanted to work out how many kilonewtons that was, you do exactly the same thing. You just divide by 1,000. So let's divide by 1,000, and that comes out, if you try it on your calculator, at 0.5 kilo newtons. What if we had double the amount? What if we had 2,000 newtons, and we wanted to express that in kilonewtons? We would divide by 1,000. Exactly the same way as we did before. You can do this with any number. If it's in newtons, you want to turn it into kilonewtons, simply divide it by 1,000. The number, if you try that on your calculator, is 2 kilonewtons. Let's have a quick look at an example. Okay, so we're going to try this exact same thing, but with some flour in the kitchen. We're going to do grams instead of newtons. So we're actually going to weigh how much mass this has, see if we can convert it. So I've got a bag of flour. I'm going to pop it on some scales, an electronic balance here, and we're going to see what it reads. So it tells me here that we have 1,500, pretty much, 1,500 grams. And if we want to convert that to kilograms, we're going to have to, divide by 1,000. Pop that in your calculator, if you've got one handy, and you should get this number right here, 1.5 kilograms. So it works with any unit. Okay, now let's try it the other way round. What if we want to turn kilonewtons into newtons? We're going to have a look at exactly the same examples down here, but work out what it is we need to do differently. Let's pop this one back up. 0.5 kilonewtons. Now, because kilo means 1,000, if you have 1 kilonewton, but you need to convert it into newtons, we know a kilonewton is 1,000. So we can use that as a basic example to try and work out what to do. To get from 1 to 1,000, we have to multiply by 1,000, and that's exactly what we'll do. Multiply by 1,000. So converting kilo, anything, into the original unit, you just multiply by 1,000. It works exactly the same here. If we've got 0.5 kilonewtons, simply multiply it by 1,000. Try it on your calculator, and you'll come out with the correct answer, which is 500 newtons. If you've got 2 kilonewtons and it's asking you to write that in newtons, you do exactly the same thing and you simply times by 1,000. And it's as easy as that. Hopefully that makes sense. Okay, so the final part that you definitely had a little bit of trouble with, some of you, was about resultant force. And what is resultant force? So I've written down something we can keep in mind. When forces act on an object, the overall force that actually causes the object to move is called the resultant force. Now, my car hasn't been used for a little while. The battery went flat and I tried to push it on the drive, but the drive's gravel. I couldn't move it. I was pushing as hard as I could, and normally on a road I could do that, but I couldn't move my car. There was too much friction holding my force, holding the car in place and counteracting my force. So there I was with my car. I'm just going to put a quick car together, see that there will do. Hopefully that looks a bit like a car. Let's put a little spoiler on the back or something. On the road, or on the gravel, I'm pushing forward. Let's say I used 100 newtons of force, but holding the car back, acting in the opposite direction, is friction, stopping the car moving. The fact I put all that effort in and I didn't get any movement means the friction would have been exactly the same, acting in the opposite direction. Now the resultant force is 0 because of the 100 newtons I put in, 100 newtons was acting in reverse. It counteracted all of the effort I put in. Resultant force is 0. However, if we have 2 people pushing, we can move the car. 2 people pushing will give us 200 newtons of force pushing forward. There's still the same 100 newtons of friction. Now the car will actually move because the forward force is bigger than the backward force. Now how much bigger it is the resultant force. So of the 200 newtons acting forward by two of us pushing the car, 100 of those newtons is counteracted by friction, leaving only 100 newtons of this forward force actually causing acceleration. So the resultant force is 100 newtons in this example. Hopefully that helps a little bit. If you've got any questions about it or anything I've said in the video, please put a comment below. If you like the video and you'd like me to do one of these each week, again, put a comment below and let me know. And if there's enough of you wanting it, I'll happily give you a video each week to help you along with things. And if you tell me what you want to see in the video, I'll happily do whatever I can to help. Thanks for coming. Look forward to seeing you on Friday in the live lesson, 12:15. See you there.